You are welcome to today's basic mechanics class. I would like to start by defining mechanics. What is mechanics? Mechanics is a branch in mathematics that deals with forces in motion. Under this whole course, we will be treating centroids, forces, equilibrium, couple, transit, friction, and wedges. Today, our main focus is introduction to forces. In this course, you'll be needing some reading materials. These are some of the important reading materials that are needed for this course. To download this course, a link will be dropped in the description for you to download these course materials. Mechanics. Mechanics has three branches. That is mechanics of rigid bodies, mechanics of deformable bodies, and mechanics of fluids. Mechanics of rigid bodies entails basic mechanics. That is the course you are studying. As you are going forward, or as you move forward in your engineering life, you'll be doing mechanics of deformable bodies. That is mechanics of engineering, strength of mechanics 1 and strength of materials 2. Mechanics of fluids, that is fluid mechanics 1 and 2. So let's go straight to our topic for today, forces. Let's study some of the characteristics of forces. Forces represent the action of a body on another and is generally characterized by its line of action, its magnitude, and its direction. The action of a force can be separated into two effects, internal force and then external force. Internal forces are forces that act in a body, and then external forces are forces that act outside the body. Internal forces can be compression or tension, and external forces can be weight and reaction. Also, two or more forces are said to be concurrent when they intersect at a point. So the example we have on the screen, force A and force B meet at point capital A. So that means they are concurrent forces. So the sum or the resultant of these two forces will be R, which will be in between the two forces. Let's look at how we can resolve forces. We can resolve forces in two different approaches. We can use the graphical or trigonometry approach or force component approach. Under the graphical approach, we have parallelogram or Polygon rule of vector addition, and then the sine and cosine rule. And then for the force component, we have the rectangular component approach and then the unit vector approach, which I will explain in the subsequent slides. Alright, so the sine and cosine rule. We can see from our diagram that we have three sides, A, B, and C, and three angles, alpha, beta, and then gamma. And then to find each of these sides, we can either use sine and cosine rule, provided or depending on the conditions of the given variables. For sine rule, we can use A over sine alpha, which is the side over the angle which is opposite to that side. And so in this case, is A over sine alpha should be equal to B over sine beta, and then should be equal to C over sine gamma. These three equations can't work at the same time. You can either use two at a time. So you can choose A over sine alpha is equal to B over sine beta, provided you have your values to find the missing value. Or you can use A over sine alpha is equal to C over sine gamma, provided you are to find gamma given A alpha, and then c. Likewise, if you want to find b and then you are given beta, gamma, and c, you can use b over sine beta is equal to c over sine gamma. We will take examples as we move ahead. Alright, and so the cosine rule. How do we use the cosine rule? In some cases, you'll be given two sides and an angle. And so in the case where you have b, c, and then alpha, and then you are asked to find a, you can't use the sine rule, because if you want to find a and then you are given alpha, fine. You can use sine a over sine alpha is equal to b. You'll be needing sine beta to find a. In this case, beta is not given. So how do you use? Which rule do you use? This is where cosine rule comes in. So in cosine rule, you can find a given b, c, and then alpha by using this equation. A squared is equal to b squared plus c squared minus 2bc cos alpha. Likewise, if you want to find b given a, c, and beta, you can use b squared is equal to alpha a squared plus c squared minus 2ac cos beta. You can use c squared is equal to a squared plus b squared minus 2ab cos gamma if you are given AB and then angle gamma. You will take examples as you go ahead. Let's move to parallelogram or polygon rule. Parallelogram or polygon rule works when you have two forces which are concurrent, and then you have an angle between the two vectors. So let's take vector A and B. If you are to use the polygon rule to complete this, what you have to do is, the first step is to complete the vector or mirror the vector to form a polygon or a parallelogram. So as we have on the diagram, now we have our parallelogram. So to continue, we divide our parallelogram into two equal parts. So we have the upper part and then the lower part. The next step is to find alpha. You can find alpha using the sum of opposite angles in a polygon. So that is the sum of interior opposite angle are equal to 180 degrees. So in this case, theta plus alpha should be equal to 180. Okay, so we continue by taking half of the polygon. So we take half and then the mid line becomes our resultant. So in this case, we have R being the resultant, vector A and vector B with alpha as our angle. With this condition, we can use cosine rule to find our R, because we know vector A, vector B, alpha, which is opposite to the resultant. So our equation becomes R squared is equal to VA squared plus VB squared minus VA times VB cos alpha. So we can find what? Our alpha. Or we can use R squared is equal to VA squared plus VB squared plus 2VA VB cos theta. The main reason why you can use cos theta is that if you have an angle which is opposite to another angle in a polygon, the sum is equal to 180. So let's take an example like we have theta as 60 degrees. So if theta is 60 degrees, alpha is equal to 120. Okay, so cos 60 is equal to half, but then cos 120 is equal to negative half. So in this case, if you put negative 120 and negative half in the first equation, it makes this negative positive. Likewise, if you put cos 60 here, it is positive already, so it doesn't affect the sign. So it makes the first equation similar to the second equation, or they are all the same, provided we take the bigger angle or the smaller angle. Okay, so let's take an example. A stick is being pulled out of the ground by means of two ropes as shown in the diagram. Knowing the magnitude and direction of the force exerted on one rope, determine the magnitude and direction of the force P that should be exerted on the other rope if the resultant of these two forces is to be 40 on the vertical, or is a vertical force 40. Also, determine the angle the 30 Newton force makes with the unknown force. So when you are given a problem like this, the first thing is to do a free body sketch, or draw your free body diagram. Let me show you how you can draw your free body diagram. So we have two forces, 30 and P. We can look at the previous 30 and P. We know the angle between the vertical plane and 30 to be 25. And then the angle between the vertical plane and then the force P is unknown. So in this case, we are using alpha as our angle, our unknown angle. And so 30, 25, vertical line, alpha, and then the force P. So to solve this, because force P makes an angle directly with the vertical plane, we can bring force P, or we can complete our polygon in such a way that force P will move to the top of the 30 Newton force. So this is how the diagram will look like in case you are to complete and then take half of the polygon. This is how the diagram would be. So this is our angle 25. The angle at the upper side will be alpha, sorry, and then the force between the force P and 30 is theta, and that is what we are looking for. So in this case, we want force P and then theta. So how do we find force P? So with force P, we can use the cosine rule. So from the cosine rule, P squared will be equal to 40 squared plus 30 squared minus 2 times 40 times 30 cos 25 degrees. So in this case, we can find P by using this formula, and our P is equal to 18.02 newtons. So now we know our P. How can we find theta? We can find theta by using the sine rule. So from the sine rule, P over sine 25 is equal to 40 over sine theta. Now we know our P, so the unknown now is theta. So we can now change or cross multiply and then make theta the subject and find theta. So in this case, theta is equal to 69.74 degrees. You can pause the video here and go through the steps one by one and determine your theta. You can pause the video and then you do that. Okay, so I hope you are done. Let's take the next example. This is the next example. It says that the cable stays AB and AD help support pole AC. Knowing the tension is 120 in AB and then 40 in AD, determine the magnitude and then the resultant of the forces exerted by the stay at A. So in this case, we have two forces. one along AB and then one along AD. And then we are saying that these two forces help AC to stay in equilibrium, or to stay at its original position. And then we are asked to find the forces that could keep AC stable. All right, and so the first thing, as I said, you draw your free body diagram, then you find the unknown angles, then you move forward to find your forces. So now let's draw our free body diagram. So the solution. So this is how our free body diagram will look like. We have a force which is acting along the cable AB, and a force which is acting along the cable AD as 40. So with the given diagram, we're given the components based on distances. So to find angle ABC, or to find angle CAB, you need to use your Pythagoras theorem or your SOHCAHTOA to find angle CAB. So to find angle CAB, you use adjacent, and then you can use your adjacent and then opposite to find angle CAB. Angle CAB now be tan inverse of the opposite over the adjacent, which is 8/10. Tan inverse of 8/10 will give us 38.7. Okay, so that is the angle here. So what's next? We complete our polygon. Then after completing the polygon, we take half of the polygon. Okay, so we now determine alpha, which is 110.3 degrees. So we all know that the sum of internal angles of a triangle is equal to 180. So we have 31 plus 38.7 minus 180, or 180 minus 31 plus 38.7 degrees, which will give us 110.3 in the diagram as shown. So we want the force AC. How do you find AC? We know AB, and then we know AD. So we can find AC knowing the opposite angle. So now it simply becomes AC squared is equal to 40 squared plus 120 squared minus 2 times 40 times 120 cos 110. So our AC now becomes 139.04 newtons. So I would like you to pause the video and then do the calculation. So let's move to the next approach, which is the force component approach. I would like to start with the rectangular component approach. So if you are being given a force and an angle theta, or a force and an angle beta, a force or the condition that is a right angle triangle given the sides A, B, and C, you can find the various components of this force. So to do this, you have to resolve the force in X and Y direction. So how do you resolve the force in F and Y direction? Okay, and so to resolve the force in the X direction, we know that this force is your hypotenuse Fx, or we want Fx. Fx is adjacent to the angle theta, okay, and F is our hypotenuse. So if we want Fx, we know adjacent and then we know hypotenuse. knowing the angle, we can use what? K, which is adjacent over hypotenuse. So you make fx the subject, which is the hypotenuse. So you get hypotenuse times cos theta. So in this case, if the angle is theta, fx is f cos theta. But in another case, if you have the angle of the and then the angle is making, or the force that is given is making an angle with the the vertical plane, that is the y-axis, that is alpha here, our fx will be sine theta. So in this case, fx now becomes what? Opposite. So if it is opposite, we use what? So, which is sine theta. So fx becomes f sine theta, provided the angle is between the force and then the positive or the negative y plane. Or in another case, if you have the force and then a right angle triangle describing how the force looks, then you can simply write fx as the force times the adjacent component of the given right angle triangle over the hypotenuse component. So in this case, it is f times b over c. So you can write fx in 3 different ways if you have these conditions given. So if you have if you have the angle between the force and then the x-plane, fx is cos theta. 2, if you have the angle between the f or the given force and the y-axis, fx becomes sine that particular angle. Okay, and then the last condition, if you have the force and then a given right angle triangle describing the position of the force, then fx will be equal to the force times the adjacent component of the right angle triangle over the hypotenuse component of that right angle triangle given. I hope you understand. Now let's go to our fy component. And so likewise, in our fy component, if the force is making an angle with the x-axis, fy becomes sine theta. And then if the force is making an angle with the y-axis, fy becomes cos that particular angle. And likewise, if you have the force and a given right angle triangle describing the position of the force, then our fy will be the force times the opposite side, that is A, over the hypotenuse side, that is C. So these are the ways you can determine or you can resolve forces in x and y components. So that is for the for the rectangle approach or the scalar approach. So in the case of the vector approach, we use I and then j. So in this case, when you find fx, you just add I to it plus fy times j. So it becomes f is equal to fxi plus fyj. All right. Let's take note of this. The position of the force can affect the signs of the components. So if the force is in the first quadrant where we have x and y being positive, our fs component will be positive and our y component will be what? Negative. In the case where the force is in the second quadrant, fx will be negative and then Fy will be positive. In the case where it is in the third quadrant, where we have all the axes being negative, Fx will be negative, and then Fy will be negative. And then if it is in the last quadrant, where x is positive and y is negative, Fx will be positive, and then Fy will be negative. Please take note of this. The direction of the force affects the sign of the force. So I would like us to take examples. So example 1, resolve the forces shown in the component. So we have this diagram over there, a 60-pound weight making, or we are dragging a 60-pound weight at an angle of 25 degrees with the horizontal positive x plane, and then we have another 40 which is at an angle of 60 degrees with the positive x plane, and then the last force which is 50 degrees with the negative y plane. So before we start everything, we have to produce our free body diagram. So on our right hand side, we have our free body diagram to this particular figure. 60 pounds making an angle of 25 degrees with the x-axis, 40 pounds with 60 degrees with the x-axis, 50 pounds making an angle of 50 degrees with the negative y-axis. So this is how you draw your free body diagram. So to solve this, we take each force component, we resolve it in the x and y direction. Afterwards, if you are asked to find a resultant, you sum all forces in the x direction, you sum all forces in the y direction. Then afterwards, you find the resultant of that, the resultant of the summation of the x and then the y's. So now let's resolve the forces one after the other. Let's resolve force 60. So if you take force 60 pounds, an angle of 25 degrees with the horizontal x plane, positive x plane, our Fx will be F cos 25 because the angle is making, the force is making an angle with the positive x plane. If it was supposed to be with the y, then Fx would have been what? Sine that particular angle. Okay, and so we resolve it in x and y. So we have 60 cos 25 and then 60 sine 25. You compute it to get your answers. Okay, so now let's go to the next force, which is 50. So we have our next force 50. We resolve the force 50 in x and then y. Okay, and so in this case, the force 50 is making an angle with the negative y axis. So in this case, y becomes cos and then x becomes sine. Okay, you can do this, or you can find the other angle by subtracting 50 from 90 to get 40. Then you use that to calculate your x and y using the normal procedure. But then since the angle is 50 degrees with the negative y plane or the y plane, x becomes sine. So now we have the force 50. So for the force 50, we have x to be 50 sine 50. It is negative because it is on the negative x axis. And then y will be 50 cos 50. Also negative because it is in the third quadrant where x is negative and then y is what? Negative. So after doing this, you compute to find the value of x for the second force and then the value of y for the second force. Now let's go to the third force, which is 40. So the force 40 makes an angle of 60 degrees with a positive x plane. So resolving this is quite easier. So we have our x to be f cos 60 and our y to be f sine 60. So for the force 40, we can write x at 40 cos 60 degrees and write y as 40 sine 60 degrees. So you compute this to get your values. The y value is negative because it makes an angle. The y value is negative because the force is in the last quadrant where x is positive and y is negative. Let's take another example. A man pulls with a force of 300 newtons on a rope attached to a building, as shown. So the man is pulling a rope which is attached to a building. What is the horizontal and vertical components of the force exerted by the rope at point A? So in this case, we are asked to find our x component and then our y component. So it's the same as the horizontal and vertical components. So how do we do this? As I said, the first thing is to produce your free body diagram. So with this is how our free body diagram would be like. The man pulling the rope with a force of 300 newtons at an angle alpha. So we are asked to resolve the forces in x and then y components. But then we were given the distances, between the man and then the wall vertically and then horizontally. So with that, we can find our angle. But I would want to use the last procedure where we consider the adjacent and then the hypotenuse, the opposite and then the hypotenuse component. All right, so now let's solve it. So from the first diagram, we can say that fx is equal to 300 cos alpha, and then fy will be equal to negative 300 sine alpha. That is from the first diagram. But then from the second diagram, I can rewrite cos as cos is equal to adjacent over hypotenuse, which is 8 over 10, which is equal to 4 on 5. So I can break this one down to get 4 on 5. So now we come to the first equation. Wherever we see cos alpha, you put 4 over 5 there to compute and get your fx value. Okay, so in the case of sine alpha will be equal to the opposite over the hypotenuse, which is 6 over 10. And then we simplify it to get 3 on 5. So now, wherever we see sine alpha, we can put 3 on 5 over there. So now let's put that inside. So therefore, fx will be equal to 300 times 4 on 5. And then it's equal to 240 newtons. Fy will be equal to 300 times 3 on 5. And then that will be equal to negative 180 newtons. So we can write this in the form of a unit vector. That is f is equal to fx I plus fyj. So now we know that our fx is equal to 240 newtons I minus 180 newtons j. So this becomes our resultant force for this given problem. We would like to take our last example, which is the forces F1, F2, and F3 are all of which act on a point A of the bracket are specified in the three different ways. Determine x and y scalar components of each of the three forces. So we are asked to find the x component and the y component of each forces. So how do we do that? As I said, if you are given a problem like this, the first step is to draw your free body diagram. So now, after drawing your free body diagram, I would want you to take each force one after the other, then you resolve to find your x and y components. So now let's take the first force, force 1. So force 1 makes an angle of 35 degrees with the positive x plane. So Fy will be F1y will be equal to 600 sine 35, and F1x will be equal to 600 cos 35. So in this case, I have my F1x to be 600 cos 35, which is 491 newtons, and then my F1y to be 600 sine 35, which is equal to 344 newtons. I would want you to pause and compute to see whether your values are correct or whether you had the same values. So after doing that, you resolve the second force, which is 500 newtons. According to the force makes an angle, or the force falls in the second quadrant where y is positive and x is negative. But in this case, we're being given the Pythagoras composition of the force. So now we can just write the force Fx as negative 500 times 4 over 5, where 5 is the hypotenuse. So if you compute 4 squared plus 3 squared all under square root, you get 5. That is the hypotenuse. So you have our x to be negative 500 times 4 on 5, which is equal to negative 400 newtons. And then our y will be equal to 500 times 3 on 5, and then that will give us 300 newtons. Sorry for the mistake made. So after everything, you go, okay, so you have our last force, which is force 3. So now let's resolve force 3. So we draw the free body diagram for force 3 to see how best we can find the angles, and then now move ahead to find our forces in the x component and then our y component. This diagram looks a little different from how we used to solve our first one. So to help you with this, I would like you to find the angle alpha, or you can find the angle between the force and the x-axis. So in this case, our alpha will be equal to tan inverse of 0.2 over 0.4, which is 26.6 degrees. After getting your angle, our work becomes quite easier. We can find our x component and then our y component. In this case, our x component will be sine 26.6. It's a messed up. So it will be sine 26.6, and then our y value will be cos 26.6 to find the value of your forces. So getting to understand all this, I hope you can try some of the examples on your own. But I added 5 try questions where you would solve, and then in our next meeting I'll take you through all the 5 examples or the 5 exercises. So the first try is this particular diagram where you have even the answer provided, Fx and then your F. So the y component of the force F, which a person exerts on the handle of a box wrench, is known to be 70 pounds. Determine the x component in the magnitude of the force F. Okay, and so we are now asked to find Fx and then F, because you've been given the y component, which is 70. So with this, it becomes quite easier. You just do it, you resolve, then you get some simultaneous equation, then you find your Fy. This is our second try. It says determine the resultant R of the two forces shown by applying the parallelogram rule for vector addition and summing scalar components. So we are using this diagram. You use the parallelogram rule. So you complete your parallelogram, then you find the angles, then blah blah blah, then you find your scalar components. It's quite easy. It's quite simple. Just try your hands on it. You can do it. It's easy. Look at the previous examples and then use that to solve these trials. The third trial is to find the x and y components of each force is shown below. You have 3 forces and then you have the corresponding angles. So it is not difficult to solve this example. Your fourth trial is to determine the resultant of the forces of the 3 forces shown. So in this case, you resolve each forces in the y and then x components. Afterwards, you sum the forces in the y component and the forces in the x component. Then afterwards, you find your resultant. You find your resultant by using the equation the sum of fx squared plus the sum of fy squared should be equal to the resultant squared. Okay, and that will help you find your resultant. So in the case where you are asked to find the angle, which you weren't asked, but if you were asked to find the angle or the direction of the force, it will be tan inverse of sigma fy over sigma fx. So it is quite easier and simple. All right, our last try question is this. Determine the x and y components of each of the forces. And then afterwards, you find the resultant both in the scalar form and then in the vector form. It's very easy, very simple. So thank you for your time. Till we meet next time, it's a bye-bye. But then I would want you to go in the description, look at the site, and then look for the course materials, the research material books, then download. Thank you for your time. If you enjoyed this course, I would please want you to subscribe and click the like button for me. Also, if you subscribe, just type I subscribe.